Kubernetes is a really complex thing. I delivered a capture the flag, very similar to this, but more advanced at Everything Open last year. I discovered from the people in the room, there were very few people who could keep up with the things that I was going through. So what I thought I'd do this year is I'd pare it back a bit and talk a little bit more about container security and trying to understand how container security is important. Because even for people not using Kubernetes, understanding how you're operating things in a container workspace is still just as important, and in fact often more important, because you have less of the control around the underlying platform and infrastructure that might be running your applications. So I'm going to talk first a little bit about myself. The worst part of standing in front of a room of people is having to talk about me. I'd much rather talk about the technology, but I do think it's important. There's a number of logos and badges that I put on the screen there. If you've read my bio, you've seen that I've been working with Linux for more than 20 years. I started working with Linux in the early 2000s, which unfortunately dates me. In 2013, 2014, I started on a project at work where I was using Docker. And I was using Docker to containerize a Java front-end application. That's not a typical use case for Docker and why you might use containers. But it was the use case that we had at the time, and there were some really good reasons for it. The reasons that we were using a Java application and embedding it into a Docker container is that the fleet of machines that I was responsible for, which were end-user desktop computers. We had somewhere between 3,000 and 4,500 at various stages of the project. And we were going through upgrading the hardware, replacing the hardware, and as part of replacing the hardware, we needed to update the operating system. We were moving from Red Hat 5 to Red Hat 7, I think it was. Why would we skip 6? Who needs 6? We were just so out of date. One of the biggest problems is that we had this fleet. We had a new operating system, we had new hardware, and we had an application that was constantly undergoing change as well, the Java application that the end users were using. For me, we chose Docker and we chose containerization because with all these things changing, we wanted to try and lock down the changes and test them individually. So we wanted to test the operating system. We wanted to test the hardware with known versions of the operating system. And we wanted to test all of those things while the changes to the application were still being done and tested at the same time. So the application could be separated off, and the application got built into a Docker container. We tested it, and we proved that it worked in a container. We were able to prove the application's faults or successes when we were testing it were nothing to do with the underlying hardware, because we were isolating so many of the things that were happening. What I didn't realize at the time is quite how little isolation we were actually putting in place. Fast forward a little bit. I've moved on from that large company, and I hadn't moved on from that company. In fact, I was at a conference, Container Camp in Melbourne. Did anyone go to Container Camp in Melbourne in 2017, 2018? Because I was working with containers, I went to a conference to learn more about what I was doing, and it was the first time I had an opportunity to stand up on stage and talk to a room of people. Lightning talks. Standing there in front of a group, giving a lightning talk about this thing that we were doing. I also happened to hear about this strange new technology called Kubernetes. Kubernetes being the new technology that had only really been released 2 years previous to that. And I said to myself at the time, Kubernetes is not important. That's not the way I'm doing things. It's not the way I'm orchestrating things. I orchestrate this with a user walking up to a desktop, clicking on an icon, loading an application that's stored in a container. Kubernetes is never going to help with that. I was ruining my words when a year and a half later I changed jobs, and suddenly I was managing a platform team running Kubernetes in the hardest possible way on our own infrastructure, our own hardware, and trying to make sure that this Kubernetes ecosystem stayed up to date. Again, I was still not thinking about the security of it. I was in a position that so many other people get into where they're focused on making the tech work and not thinking about all of the negatives around it. And I promise, this story about me is going to end soon, and we'll move on to some of the more technical things. Needless to say, I learned so much, and I moved on from that job, again, 1.5 years later, into a role as a consultant. And ever since then, I have been a consultant, and I work as a consultant to help people who are using bleeding edge technology, and I still consider Kubernetes in Australia to be fairly bleeding edge. I help them do it better, and I get to see lots of different instances, but now I do it from the focus of security. I started working for a consultancy. I'm the only person in Australia working for Control Plane. That's the logo down the bottom, that's this logo on my t-shirt, and that's the logo on the flashcards that I've got over there to help you learn some of the concepts that we're talking about with Kubernetes and security. Control Plane, there's only between 50 and 60 of us at any one time, but we are world-class industry leaders in cloud-native security. The team of people that I work with have literally written the book on hacking Kubernetes. They've written the book on cryptography and how quantum computing and Kubernetes work together. I've got colleagues who have written white papers around eBPF and securing through the kernel. My colleagues are fantastic, and I always feel like that the outsider when I start talking to them, regardless of how many years I've been working with this technology, because they are that level. But I help them get a footprint in Australia, and part of that means I get to come to conferences and community events like this. By coming to community events like this, I've got very involved in other community events. So I help run the Melbourne Cloud Native community. I organise CloudCon in Sydney. I'm a CNCF ambassador, which means I have to talk to people as much as I can about the CNCF toolkit. I am an active participant in the Cloud Native Security Technical Advisory Group, STAG. There are two versions of STAG. There's one that works in the APAC time zone. There's not very many of us that operate in that time zone, and everyone else operates across either the EU or the US time zone. So I now get as heavily involved in all these different open source security initiatives as I can, which kind of gives me a bit of an insight into what other people are doing and how other people are working as well. And to top all of that off, to improve the way that I stand in front of an audience and talk, I then set up a Toastmasters club in Melbourne where I help other people learn and practice public speaking skills and techniques, most of which I'm not using today, but I'm using some of the thoughts about it instead. I wanted to bring this up as a very early stage of the tutorial today. This is what I consider and I think about when I'm looking at how to attack a Kubernetes cluster or a platform that is running containers and might need to be attacked. Why do I think about attacking it? Well, because the best way to know how to defend against an attacker is to use an attacker's mindset. So I talked about my colleague who wrote the book about hacking Kubernetes. I talk about all these security groups that I'm part of and how I get involved in those. And the view that we always have in all of these ways is that understanding what attackers could do, might do, or would want to do makes it much easier for us to then work through how we are going to defend against all those things that an attacker might do. Understanding what the attack surface looks like and how to start working your way through across some of the different arms. And we have broken it down into process, runtime, network, security, and file system so that you can start branching out from the workload that you want to attack and start looking at how you might, once you're into a workload, break out from that single workload that you've attacked into something else. Pen testers, when I speak to pen testers, most of the time the pen testers I speak to are more focused about popping the hood and getting in from the outside. And especially when I talk to them around the cloud native stack, they talk to me about how they've exploited an RCE and they've got in and they can see the workload. And I said, so what do you do next? Does anyone know what they would do next? They don't know. So these pen testers, they might breach and say, oh yeah, we've managed to get into your network. But what's the scope of that breach? What's the impact of them coming into that single workload? And if you haven't thought about it, and if you haven't threat modeled it, and you haven't worked your way through and understood what happens if someone gets into this workload, these are the ways they're going to go from that workload to other parts of your system. And actually, when we talk about defense in depth, sure, put the firewall on and try and prevent someone from coming into the top of your application and popping one application. But it's equally, if not more important, to then make sure you've got multiple layers of defense across all of these areas to start preventing people from moving further. The other concept I wanted to talk quite a lot about as we go through in the slide part, before I get into the technical, is the OWASP Kubernetes Top 10. Does everyone know what that is? Has everyone read into it to some extent? Not at all? No, cool. So it's a little bit out of date. In 2022, when adopting Kubernetes, we introduced new risks to our applications and infrastructure. The OWASP Kubernetes Top 10 is aimed at helping security practitioners, system administrators, and software developers prioritize risks around the Kubernetes ecosystem. The Top 10 is a prioritized list of these risks, and in the future, we hope for this to be backed by data collected from organizations varying in maturity and complexity. That's a quote from Jimmy Mester, who wrote that in 2022. The idea of coming up with these top 10 was so that system administrators and practitioners knew what the risks are and could start to identify how they might deal with those risks in a proactive way. 2 months ago, they closed the survey. Anyone who's seen me on LinkedIn, you probably saw me posting a number of times, the only social media that I actually have to work on, posting numbers of times about the survey being open and practitioners of Kubernetes to start talking about the risks that they thought about and saw in their ecosystem. Because this top 10 is a great way of doing it, but it was written from one person's perspective and the information and the knowledge they had. And what we want to make sure is that the new survey has now closed. We're going to update this list sometime soon. But the list should capture as many people as possible so that we understand the risks from all of them. So, virtual machines, containers, container security, how are we going to do it? What are the things that people misconfigure the most? The first thing that people misconfigure is not because they're misconfiguring something, it's because they don't necessarily understand the difference between a virtual machine and a container. And so they'll treat a container as if it's a virtual machine, and they'll think about the security that they would have put in for a virtual machine, and they'll try and assume that that security applies to a container as well. VMs provide much stronger isolation, but they have such a heavy footprint. So containers, they're lightweight, they're fast, they start up, they shut down, you can scale them really quickly and easily. The idea of having this policy and having the fidelity of policy means that you can work out what your container should be able to do and lock everything else down to prevent it from doing other things. You can see the stack height. The guest OS on there looks massive. And while people think about containers having an operating system, they don't actually have an operating system per se. A container, did anyone go to the OCI artifact talk yesterday? A few people there? So it started to break down what's in a container. And it's just a series of files with references and links in different layers so that you can update and change things in those different layers. The misconfiguration typically will happen at some point through that container image, and the things that you're putting into it or not putting into it, or not knowing that you've put into it. So some of the high risks with container security is that not everything in Linux is namespaced. So the kernel module, not namespaced. System, bits of proc and dev, not namespaced. The idea is that if you have access to these areas, then you might be able to go from there. And remember the workload attack surface that we talked about? Being able to get through different parts of the process file system or runtime, because of those non-namespace things, means that you need to put an additional layer of control in. Docker is probably the most common way that people run containers until they changed their licensing, and suddenly Podman became the way that everyone runs their containers if they don't want to pay the license. I think that's such a lesson that people could have learned from history. You change the license and suddenly everyone disappears.
Do they disappear? Or do they just not tell Docker about their license?
They fade into almost insignificance. We'll still talk about Docker, and Docker haven't completely killed themselves because they're so synonymous with the way containers work, and they've diversified and they do slightly different things, and they've tried to get everyone back on their team by giving them free hardened container images. Has anyone seen about the free hardened container images that Docker are now trying to provide? So it's the latest buzz in the container security game is about hardened images and making sure that the images that you're using for common pieces of open source software have been hardened in multiple different ways. Docker, as a way of trying to get more people back in, have started to provide hardened container images that people can use. Otherwise, you have to potentially pay ChainGuard to harden it for you, or use any one of the other multitudes of hardened images. They all have benefits. They all have their own advantages, and I wouldn't look down on any of them. They all serve a place in the market. But Docker is trying to bring people back because they understood the licensing that they did push people away. So Docker runs as root typically. That means as root user, talking to a room of Linux aficionados, you have access to so many more things. You should not be running it as root. So there is rootless Docker since version 2010, but it's still not the default, and people still don't apply that. When you read the Docker install instructions, the default way of setting it up is still having root level access. So if you want to take one lesson away and you're using Docker, don't run Docker as a rootful user, run it rootless. Containers also have a shared kernel. So we saw in our stack there a minute ago, the host operating system covers all of it, and the Docker daemon sits on top of the host operating system and utilizes the Linux kernel that is shared with everything else that's sitting there on that host machine. There's nothing to say you can't take a containerized workload and put it onto a virtualized workload, which is how large enterprises do it, and it's how they get the benefit of virtualization security as well as the fast flexibility of using containers. So those are the high risks. What else are we going to talk about? Prevent many attacks through isolation and strong default configuration. This is the piece, in my experience, where most people fail. This is where people will look at the README, and there have been some amazing talks. There's been an amazing talk this week about READMEs and how good READMEs are written. They take you through a pathway. And the idea is that there is documentation to take you on the other pathways. But one of the things that I sat there and listened to when they talked about READMEs is that I know how misconfiguration in the simple path, or the developer's approach to getting it done as quickly as possible, often leads to security challenges down the line. Understanding defaults and the strong defaults that you need to put in place is how you'll prevent attacks through your container workload. Containers help you to minimize the attack surface. The idea being that you don't want to have heaps of different executables and binaries all running within one container. You want to isolate them. So the general rule of thumb is that you have one application per container, and each container then talks to other containers that are all running different applications as well. The idea of that is that the container becomes some sort of isolation boundary, and you can start to manage the network traffic and the file access traffic between those containers as they operate. the more separation you put in, the more controls that you're then able to look at, the easier it is to reduce that attack surface and make it more difficult for an attacker. Speed of deployment encourages software updates. The idea of this being that you take your container, you can change it really rapidly, you can roll it out really quickly, and the process of building a new virtual machine and waiting for that to start and do all of the things that it needs to do is much longer than it would be with a container. I'm going to skip some of these and talk instead about Kubernetes. So, let's talk about some of the extended security features. I can see a few faces fading and I want to get to the technical stuff there, hands-on keyboards, and I can see most people have got a laptop, so I want to make sure that you've got access to the system that I've got. I haven't counted how many people and make sure I've got enough systems up. So, extended security features with containers. One of the things that we look at is introducing hardened kernels. The idea here is that the Linux kernel does a lot of different things, but if you can restrict out the system calls and the capabilities that the container has access to, using a whitelisting tool, seccomp, AppArmor, SELinux, these are all different tools that give you the same capability or similar capabilities to start preventing your container and your container runtime from doing things that you don't want it to be able to do, or at least monitoring to see whether it's doing something that you didn't think it should be doing or would be doing. So AppArmor and SELinux, both equivalent and provide that low-level file system access monitoring. That means you can understand whether it's doing what it needs to do, whereas seccomp is then starting to look at the system calls that it's using. So just breaking out the differences of those. When we break into a Kubernetes cluster, the first thing that we want to attempt to do is to drop to an unprivileged user somehow. Drop to a privileged user. So you want to escalate your permissions and get to that privileged user namespace as quickly as you can. And so we talk about using the Docker file to make sure that you're not leaving it set as the default. You're not running it as whatever user has launched the container runtime, but you're setting and initiating a user and a user group. We talk about reducing the attack surface as well. And I spoke about that previously, but the steps that we've pulled out in here is about running from scratch. So does anyone know about container multi-builds? Couple of hands, couple of nods. So the concept with a multi-build is that you don't end up with the tools that built the container in the container. You start from one baseline.
Multi-stage build, yeah?
A multi-stage build, yeah. So you start with one container image, you do some things with that, you have some output, and as part of your Docker file, you determine what stages are going to occur and what containers are going to be built as part of that. The final container that you end up with is the one that you actually want to use in your system. And this is where we start talking as well about no -- privileged containers. So removing the privileges, removing the capabilities, so the dropping capabilities that you don't need, dropping all capabilities and then only adding in the ones that your application is going to need are all ways of securing your container image. The other thing we do, and again, if you think back, I'm going to come back to it, I'm going to keep referring back to it. This purple section down here, the file system section, how do file systems get added into container images? There's two very specific ways. One, someone accidentally put the files in when they built the image, and so they're accidentally there even though they didn't necessarily mean for them to be there. Or they're mounted in after the container is initiated. See if I can get back to the... yeah, so mounting volumes with read-only, no executable, all of these things are not the standard, not the default configuration. So if you haven't thought about removing these things or preventing people from running containers like this, preventing people from mounting in a read-write capacity unless they absolutely need to, then the defaults just allow you to do whatever you want. We talked about running the Docker daemon in rootless mode, but we haven't talked about signing images. And I know part of a good CI/CD pipeline when you're building the images that you're going to use in your production environments includes using something like cosign to sign the image and understand the provenance of that image. The provenance of an image being where have all the pieces in that image come from? What steps were taken to install them? What libraries, what versions? Understanding the software bill of materials, and then cryptographically signing all of those things together so that every time that image is run, you can A, validate that it is the same image that was signed at the end of the process, and the software bill of materials that gets associated with that tells you exactly what was there and what versions of things you had in case there's a compromise on something. We talked about running as root. I've talked about read-only file systems. I've talked about privileged containers being disallowed, and I've talked there about resource constraints being enforced. So that's the capability drop and capability add as you need to do different things. These are all misconfigurations that I see almost every day. And those of you who raised your hand earlier saying, yep, I run Kubernetes, I hope you all think about these things and understand how you would start to restrict things within your environments. This slide talks about K01. And I'll make sure I've got to the right thing. I'm pretty sure we're on the right thing now. So K01 is the OWASP Kubernetes top 10 number one thing, the number one reason of insecure workloads or problems within a Kubernetes environment. K02 is the supply chain vulnerability side of it. So container images should be created using minimal OS packages and dependencies to reduce the attack surface if the workload should be compromised. The early slides that I talked about reducing attack surfaces. We talked about signing and understanding what's in the supply chain. The number 2 risk from 2022 was supply chain vulnerability. I would be shocked if that wasn't the number 1 risk at this stage in time. And I'm really keen to see the results of the survey when they come out, because I see this as a much higher priority. The vulnerabilities in the upstream supply chain, and especially when we're talking about open source software and the fact that you don't necessarily know who the maintenance team is or who's providing the packages that you're then relying on. Everyone's seen the meme, right? With the one little package at the bottom that's open source, maintained by one old guy in some random country. Nebraska. That's a pretty random country, yeah. But everyone builds on top of it, and if that one piece tumbles, the implication through so many different economic, social, and enterprise setup is going to be massive. All right, number 3. The third on the OWASP top 10 is overly permissive RBAC, and the practical stuff that we're going to work on really heavily focuses on this. The idea of being able to use role-based access control within a Kubernetes cluster, less so when you're thinking about containers and running containers in other systems, more so when you're talking about Kubernetes, whether that's managed Kubernetes or unmanaged Kubernetes. Understanding the role-based access control and how many people have access to do things that you probably don't expect them to have. Role-based access control is based on verbs, resources, and objects. So get, create, delete. One of the things that I learned pretty early on was that the ability to list secrets is as synonymous with the ability to get secrets and understand what secrets are in there. In Kubernetes, and I'm probably going to talk about this again, secrets are not secret. There is nothing secret about a Kubernetes secret unless you've gone through a whole heap of trouble to properly encrypt it. because secrets in Kubernetes are just encoded. They're stored in plain text in numerous places around the system, and having access to any one of those places, especially etcd, which is the key pair store that Kubernetes is based off of, allows you to see any secret that's in the system because it's not secret. Is anyone, again, I'm just interested, is anyone still just using Kubernetes secrets as the way to keep things secret? Anyone wants to admit to it? Okay. There are alternatives. I used to talk about HashiCorp Vault as being like the premium alternative to this. HashiCorp Vault is probably not the premium anymore, although the pricing would suggest it is. There are now multiple other ways of doing it, including OpenBow, which is the open source HashiCorp Vault. And OpenBow never used to be a serious contender, but there's been so much work been put into it in the last little while that starts making OpenBow enterprise ready. Ready for replication, consumers to use in lots of different places, ready to scale across large, vast enterprises. It's going to be a big change in the next few years as more people move away from Vault and the high prices they were paying to access enterprise features and see some of those features in open source. Number 4, policy enforcement. So using pod security standards via admission control, looking at privileged, baseline, restricted, understanding the levels that your pods are running at. So to break down some of that terminology, a pod is the smallest unit of work that you have in Kubernetes. A pod may contain one or more containers, and those containers are stored, they run on the same host, they operate within the same network namespace and file system namespace. So they have access to the things that the other containers have access to, but they are separated out and they operate as a pod of containers that you can then move around and do whatever you need to do with. Enforcing how those pods get started and the kind of defaults that are there, that's where the privileged, baseline, and restricted default pod security standards come into play. The more restrictions you put on it, the less usable it is, but the more secure it is. And finding that balance is how you get security right with cloud native. Anything in the cloud native ecosystem is the balance between usability and restriction. Number 5 on the top 10 is inadequate logging and monitoring. And again, I talked about the virtual machines versus containers divide and the fact that people don't necessarily understand when you've got a virtual machine, it's always there. The logs for it will be there pretty much indefinitely. And they'll get stored on that virtual machine and they'll get sent off to a log server and they'll always be able to tie back to that virtual machine. So if something goes wrong on the virtual machine, great, you go and have a look at the machine and you can start doing your forensic investigation. A container is designed to be ephemeral. That means it will be started and relatively quickly, potentially within 15 minutes or less, that container can be gone. I don't know anyone who's got logs that are replicating, being checked by a SIEM or a security team that will see a problem and connect into the container within those 15 minutes. So if you're not collecting logging and if you're not monitoring things effectively, that means the forensic investigation that you could have done and you would have done if it was a virtual machine, you've lost the ability to do that. The container has disappeared. Threat number 6, or number 6 on the top 10 list is broken authentication. People often look at Kubernetes, containers, the cloud native ecosystem and think authentication is not really that important. And especially within Kubernetes, there isn't really a concept of users. There is a concept of a service account, and a service account might be a human, or it might be an application, or it might be a process. And there's some levels of differentiating between it, but there's no real username, password, login. Especially in the default setup, there are ways of enabling username and password, which don't do. The idea is that you offset your authentication and your user logging into a system to authenticate, and then they get a JOT token, and that JOT token is used all over the place to authenticate who they are. If something breaks in that toolchain, as can happen fairly frequently, if the tokens are not short-lived tokens, or if they get left lying around, then that's another key way that people will break out. And again, in the technical scenarios that we go through, that's definitely going to be in there. Number 7 on the top 10, network segmentation. Kubernetes networking is flat, which means everything can get to everything and everyone can talk to everyone. We talked about our isolation layers, and if we went back to the model at the start, the network section, there's multiple different ways of breaking through the network. Understanding what you can start adding to your Kubernetes cluster is the way to start introducing the controls that you need around network segmentation. So being able to block the Kubernetes namespaces from talking to other Kubernetes namespaces, being able to block Kubernetes clusters from being visible from the external internet. These are all things that you wouldn't necessarily do straight off the bat as a default configuration if you were Kubeadm installing a Kubernetes cluster, but they're really important to do. And understanding who can get into the network and what they can see once they're there gives you an insight into some of the risks. I briefly talked about secrets management already, but secrets management is on this top 10 list as well. Secrets are not secret. So secrets get pushed into environment variables. I see that a lot, where the plain text username password is just there as an environment variable. That means anyone who can query that container with some fairly low privileges will be able to see it. Anyone who can query the node with, again, fairly low privileges would be able to see it. So having it there is not a good idea, but it's very frequently done, not necessarily for misconfiguration, but not understanding quite what the benefit of having those hidden is. You can see on the other side of the screen there, and I know it's probably really difficult to see from the back, but you can see a secret on there. So this is the Kubernetes secret, and suddenly the username's disappeared and the password doesn't look like a password, but it's not disappeared, it's just base64 encoded. So if you know how to decode base64, then the password is still in plain text. OWASP number 9, misconfigured Kubernetes cluster components. This becomes a lot less prevalent, but typically you'll see that a cluster has multiple things that are inside it. This used to be a big problem when you had dashboards within Kubernetes clusters. We've moved away over the last 5 years of having dashboards visible for people about all the things that are there. Although I would now say, with the rise of MCP, badly configured MCP agents could still be a misconfigured cluster component, because the MCP agent typically needs to have full admin permissions across your cluster so that it can tell you things. And if you ask it to do something, then the MCP agent would go and do things as if it was an admin. So overprivileged user. Finally, number 10, outdated and vulnerable components. We're going to be doing an exercise right now that uses Kubernetes 124. Kubernetes 135 was released in December. So it's 11 versions out of date, and the components that are in it have multiple CVEs, some of which have been patched, some of which I know definitely in the cluster that I've spun up for you haven't been patched. So there are multiple ways to break and attack that cluster. I'm not going to talk through, that's fine. Let's get some clusters going. So bring up simulator. So there's a number of these things, these simulators for Kubernetes. But one that Control Plane open sourced a number of years ago, and then you can see it's pretty out of date, is Simulator. The idea of it was that we wanted to give people an opportunity to play some capture the flag scenarios, to have some infrastructure that they could set up that would show them a lot of the top 10 risks that I showed you there and understand the impact of them. What I've done and what we've done, Control Plane runs the capture the flags at all of the KubeCon events. So KubeCon North America, KubeCon EU, we did KubeCon India last year, KubeCon Japan. We provide this as a gaming environment, and we have a number of different scenarios that we provide to the CNCF. We've got the early ones that we've got available for free that are in this open source repository. And that's the one that I've spun up a set of servers for each of you today to be able to access and play through. What I'm going to be doing is I'll give you guys access to it, but I'm also going to be going through how I solve a capture the flag. Last time running a capture the flag was, I think, a fair bit complicated. I think there's only one person who actually completed it, and it took longer than the 4 hours that we had allocated to do that. So it doesn't take me that long. I want you guys to play with it, try to do things, but I also want to show you how I do it and how I approach them so that you can take this away and practice it and learn it. This one is out of date, and I wanted to use this one because it talks to the OWASP top 10, the most common misconfigurations, but it also is available open source so that you can not just do it today with the infrastructure I provided, but you can spin it up in your own environment as well. The easiest way for me so what I've got is I have a number of tar packages sitting here on my laptop. I normally put them into a Google Drive, but I haven't done that yet, so I will be doing that very shortly. And the one I was testing last night looks like it has failed, but what you'll be able to do is you'll log in, you'll see a map like this, and it gives you a kubectl command line and a pod that you can start to enumerate your way through using that attack surface that I came up with, and I'll show you my way of doing it. The command to run from the package that I give you, you'll have a number of different files that are in there. They all just take you to different bits of infrastructure. Let me get a Google Drive up and available, and then we can run through that. So the only things you really need is an SSH terminal and the initial access to the public Google Drive that I will try and put up on screen in a second. My Python script broke last night, so I spent a bit of last night going deep diving on Python. It turns out the last time I ran it, or between the last time I ran it and this time, I've updated Python on my laptop. It doesn't work with the newer version.
You can fix that with a container.
Yeah, you can, for sure. And that's exactly what I've done to spin up all the infrastructure. The only downside to it is that it then is missing all of the other tools that exist on my laptop. The downside of containers is that I'd have to put all those other tools into a container as well and get them to talk to each other. Has anyone got questions for me while I'm doing this in the background?
On the storing secrets in environment variables.
Yes.
How have you in the past dealt with combating that paradigm, which is so blatantly perpetuated by like 12-factor app practices? Everyone's like, oh, I'm going to build a 12-factor app and I'm going to put my secrets in the way they say. And, oh, environment variables, sure.
Yeah. Look, the easiest way to deal with it is through education. But you can't always educate people and they don't always get it. So what I frequently do is use an admission control, and the admission control is the mechanism. So you can either just watch for what looks like passwords and secrets in the configuration, or you can.
I suppose I have one for the room. I figure people probably do container builds quite a bit. One of the patterns that I usually see that drives me nuts, people doing, say, like curl some URL on the public internet, pipe to the shell as part of your container build. And it's like super common for people to build containers by basically just running code from the public internet as part of their container build. And getting around that, it usually requires a bit of bespoke code, downloading artifacts, making sure that you've got hashes and everything to mitigate against supply chain type things. But is there a standard, has the community come up with any sort of standardized solution for doing that? Is there any tooling that go away? Or is it just a matter of finding it when people do that and telling them not to do that anymore still?
Go on, someone answer. How are you guys handling it?
Nobody has a problem with installing things off of random URIs?
You name it. I feel like
I think education is the answer. No, really.
I feel like the only other way that I can think of, the one I've come across that for container builds is like referencing a particular like install script. And yes, I guess you're still referencing like or either downloading that specific install script and as part of your like Docker build, like with that as a file to run. That's I feel like, especially if that's the only way, then like I feel like that's the only thing you could do.
That's typically what ends up needing to happen is you wind up having to just go take apart
Yeah.
thing and then take the pieces and then make sure that you're dealing with known assets. And
Usually the scripts themselves aren't that complicated, so that's I've only had to do that maybe twice, maybe, and I'm not a very massive kube. Container
it's a
person.
bad enough habit and it's common enough that I figure someone would have tried to come up with some standardized way of solving it. But okay.
In very locked down environments, they have like a proxy as a package manager, so you never actually ever go directly to the internet. It's sort of there's a proxy that downloads all the components, and you actually have to point to
Cache the bad behavior. That's okay.
Catch the good behavior.
It frustrates the developers, but yeah, in the lockdown environment, it's all.
Evil bit. Maybe just check for evil bit is set.
Oh, right.
Just wget or curl the script to begin with.
Obviously.
Yeah, but so many people don't will just again like run this thing. And like we've seen it for years with like commercial software installs even. It's amazing how many things are RPM minus no deps minus force, which is healthy. I could name some vendors, but I shouldn't. And then isolating, doing everything under like a user with very reduced privileges. If you're trying things out, sandpit it. One of my favorites with it's actually goes to the point where I'm running a VM with a sandpitted user, but when I'm getting to real deep levels of untrust, whatever's going on, but it's there was the AI lab here the other day, which required you to install a tarball from some third parties without legal reason protection.
It's kind of a shame because it seems like everybody has to come up with their own solution to this and they're all kind of bespoke and be able to leverage each other's work. Basically.
But with like our Kubernetes platform OpenShift, there's a lot of really cool ways to trigger builds into the point where you point at someone's Git repository and just back in, try and work out what code base it is and work out how we should build and turning that happen to a container for you automatically without actually, or you can just embed some additional build information that's better informed.
Okay, so I've got a link up there. Sorry to interrupt. It was a great conversation, and I'm like, but I want to get some people going. So, if you don't trust a short URL, then the full URL is up there. It's not easy to type. That's the only problem with it. So I have just done a short URL of it, and yeah. What you should see when you get to it. So there's the short URL from my long URL. It should get you to my folder EO2026. There's a file in here called taken. So once you download one of these tar zips, that's yours. That takes you to your set of clusters. So drop the tar zip into the taken so no one else gets it.
Sure.
Oh,
Roll back up.
yep.
Linux. GP.
Uppercase G, lowercase p.
Yeah. G lower P.
We're not allowed to move
Yeah.
from the taken folder.
I'm not allowed to what?
Move it into take.
Oh. Okay, let's solve that. There's a permission. There must be a permission thing on there. I just can't find my mouse at the moment.
That is misconfigured.
Okay.
What's in this tab?
I can pick up tasks.
Addressing.
Everyone edits it.
Only
Building with files. All right, then what do you need to do with it? You need to
So I'll set that, let me see here, level 3. I'm gonna plow it over on. I'm just guessing it.
I should have 28 different servers there, so I'm hoping there's enough for everyone in the room. Or those following along online, I haven't even looked at or chats anywhere.
Script, yeah.
Still got
Unable to live it.
Yeah. You are. If you want to,
it's disappeared somewhere. Like
I just heard of it. Can't tell you.
Which one have you taken?
Or if the
Okay.
83.
4F.
It's not alphabetically sorted.
Or FDB. That one. Anyone else want to call out one they've got?
I'll grab B205,
Sorry, say that one again.
Delta 205. Up to.
That one?
Yeah.
One D.
It wasn't a top before. 1377.
913.
I have the one starting with 2, please.
2EC.
Thank you.
Which one did you do? Shorter rolls, so it's not whatever you do.
Isn't going to be anyone. Should be able to move it.
Once you've got it and you've untied it, from within the directory that unties, you should be able to run an SSH command like that. Grab this as well. Oh, yeah.
Trying to connect, but I'm not getting anything.
Not getting a response. Let me just make sure they are up and working. Tested one last night, it worked fine, but that was last night. Today's today.
Yeah.
And now you're doing a demo.
And now it's live, so you go.
Gee.
And everyone gets the same error, do they?
Just saying connecting. If we're on in debug verbose mode, it's connecting on port 22.
Okay. So I'm going to take 73F to.
Amazon having an outage?
I'm not being honest, just something don't know. You just need to. I think we. I know. It's just funny. No, funny. I mean, funny people. I mean, yeah. Oh, that's it. Yeah, just tell my boss what's going on.
Should be able to. That's not legible at all, is it? Let's do it somewhere else.
It's if you can't access your Kubernetes cluster.
Well, mine's not accessing either. So this is
Something's wrong.
something is wrong. And they've all been randomized as well. So it's not like it's like one or two good ones and nothing else works. Unless there's something on the Wi-Fi blocking.
I just tried it tethering to my phone and I get network is unreachable.
So you get network as unreachable, both
Tethering to my phone.
tethering and routing.
I mean, I'm on Edgerome, so I'm on
Different network, and it's still not.
I basically just get it timing out. Well, it's not even. It's just like connecting to blah 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 port 22. It's like it doesn't do anything.
It'd be easy.
Yeah, if I try and do it via home, same issue.
So there's probably some security bots come through to realise they're open till 22.
We're now on a list.
Yeah.
Already been owned.
Also, that's failing because you're putting a dash V after dash I.
Yes. Yes. That would not be the right spot.
Beat me to it.
Where's the map?
It's the first part of the test.
This is the first part of the test. Yeah. Normally it's so smooth, and I don't have to think about it. So now we're going to have to do the old logging into AWS. So basically what we've done is we've spun up a whole bunch of EC2 instances. That's what you'd see from the open source version of it as well, as it says, work out what your cloud provider of choice is, and then run these scripts. The scripts will generate the EC2 instances, run Kubeadm,
This is my problem. Yeah. Was this someone else is talking about? Microsoft 340.
Well, all of my instances in AWS show as terminated. So that would explain why.
Very secure.
Yeah. Now, what's really secure though is I've only got read-only access. I'm gonna have to try and get it to spin me some more ones up. Yeah, that that 100% explains it.
Some stickers.
Okay.
I'm missing some stickers. Oh yeah. Yeah.
But I just come.
Which company?
Yeah,
Oh, yeah, that's it. Yeah, read it. Okay, good.
but they changed.
No, no.
We're pretty up. You know, online.
One of my previous workplaces, that was it. Everything. Not in, yeah.
They changed it.
I wonder whether we've just gone over the midnights.
It sounds. All three was. Let's wait for those first.
On my old laptop, there's so many stickers on it. Well, very carefully. Yeah. I then spent about 3 hours with WD-40 trying to get all the sticker written
Yeah.
up. The guy that took my laptop, he's like, "Why does it smell of WD-40?"
It's easy as well. Okay. You've got competing now.
We partner with both.
Okay.
Customers. That's the benefit.
Cluster admin.
Yeah. A lot of people, even on Bob. It's quite interesting. Or if the whole.
We've only got 25 minutes left in the tutorial.
I'm hoping that I'll get a 1 up and then
You
I
get one up and show.
I can show it from 1. That's where I'm aiming
Yeah,
at.
I don't not
25 minutes is tight to get through it all, but I reckon
Running on this.
okay.
Okay.
The European customers like to use it. If you have any, but
It is Germany. Yeah, we work. So Europe, we have 1 year.
all right, I'm monitoring at the moment. I'm just waiting for the first one to show that it's ready.
Yeah.
And then as soon as it's ready, I'll demonstrate it.
Meet up.
We've obviously got like a 30-minute break between the end of this session. The lock note, if we need to finish.
Well, what I'll do is I will replace all of the scenarios that I had up there, the bundles, and I'll leave these open and running for a little bit longer so that people can jump in and play on them.
yeah.
But we're also.
Still crypto miners,
Yeah.
Kubernetes Cluster developers.
So I run these kind of sessions. I go around to various businesses and run training sessions like this as one of the things that we do. And I always say that the rules for us providing the infrastructure is don't be a dick. There's things that we've protected against, but there's also things that we just can't protect against. So having a bunch of EC2 instances available for 24 hours.
Is 23 hours, 58 minutes too long? Or?
Yeah, at time.
Tuesday and everybody else.
AWS
But not AWS, but not
We've got to the point right now when we're spinning up
as well.
shift clusters with and stuff.
Yeah.
Because they're usually using some corporate laptop, we've got to make sure we don't just use self-generated certificates anymore, because that's usually just, they can't override it, they can't get in.
Yeah.
All those fun and games. It's like there's still quite plenty of organizations where they still want us to try and supply the hardware for these labs, and we just don't do it anymore.
The thing that we do here with the tar bundles was the best solution we could come up with of how you can provide SSH access to something where people can get in, but it's very temporary and ephemeral. It's still not perfect.
I don't know if we've published the way our lab front end thing works, because effectively you go to one URL, you give it an email address, and it then gives you all your lab credentials on that web page. And we know who's using which set of credentials as the lab operator. And it's not logged, it's just kept for while those labs are online. So we know who's in which lab. So you put anything you like in, it doesn't have to be an email address, which gets amusing.
Can I ask a question about,
Definitely.
so you know about all the sort of like the OWASP Kubernetes top 10, but do you are there like say scanner, like sort of scripts that scan, okay, your system, and it's within the container or outside in the control plane area, like, and tells you when there's one
But
visit?
everyone, 2024 into 2025 was the year of security tools telling you, here's a dashboard that tells you how amazing you are or amazing you're not. So yes, there's plenty of tools that will scan and will have their own level of, you've done this right, you've not done this right. The value of them is configuring them for your environment and your use case. This is why I say education is so important about this. Understanding what you can or can't do in Kubernetes and what the defaults are. Whether you're using a cloud provider or a SaaS provider to provide the Kubernetes cluster for you and you're clicking a button, there's still defaults that are there. There's kind of benchmarking tools. So the sys benchmark is probably really good for going through and going, you've done this, or your cluster's configured with these problems, and here's the steps to go and resolve that. So there's plenty of ways of getting some level of report. Specifically for the top 10, no, because it starts to look at the risks outside of just the cluster. Like you can scan for secrets. So there's tools that you can use to scan for secrets. There's tools that you can run that scan for kind of misconfigurations in various different places, but they're normally focused on specific sets of configuration and specific tooling. So there's no one tool that I can recommend. And typically, I think the best tools for it are what the hackers are using. So, and they change all the time. So I go on GitHub and look for pen testing tools for Kubernetes and see what is getting the most love.
We commission a lot of penetration tests ourselves. We deal with a lot of penetration tests that our customers have commissioned. And we've seen so many reports, you can tell the good testers from the bad. And a lot of it's just recycled crap that no one's dug into. And then you come across a report where someone's looked at the top 10 and yeah, that's fine. But they've really gone like 2 levels deep. And they've got some real penetrating insights. So people you make a note of, and you're like, okay, know what you're talking about. You're not just going to give us a report that lists the top 10 and says you're vulnerable.
All right, I have one available. I have a few of them that are showing as available, but one of them is bundled and showing fully available. So let me scrape it down. Let's see if I can access it. You were saying about the front end. We've kind of built out this thing called Kubeadm that I'm kind of showing here. Kubeadm is what we try to do is taking our open source tool and making it into a commercial offering. We never got any orders for it, therefore we never finished kind of working on it. It does work to an extent, but I've basically used the Python shells that are hidden behind all of this to spin up all the infrastructure on all of the events that I run with this, and it works better. It's something that I always look and go, I should come back to that and try and solve it at some point. I have scraped my thing, so let me pick a number, 1466. All right, so for all those files that are there, -v.
Hey!
All right, we're in. How is that legible enough?
Should nudge it up just a notch or two.
I'm not really sure.
Good enough? All right. I have it on the keyboard here, so I should be able to do it slightly better. So the first thing I always do when I come into a cluster that I'm trying to investigate is start looking at files. One of the things that I see in here is the fact that I can see the root folder, I can see the proc folder, I can see boot. So it kind of gives me a bit of an understanding of what level of access I might have wherever I've landed. So root's available. Let's have a look at root. Let's switch me over to here. I always look at root / and the home directory just to see what's kind of around. Those are my favorite places to go. Looking at the home directory, we can start to pick up a couple of things that are on here. So there's a diary MD.
So, are you currently on a Kubernetes node?
I'm currently in a pod.
Right.
You don't always, I'm not always going to, like the scenarios that we provide don't always end up in a pod. Sometimes you end up in a node first and then get to a pod. I know that this is a pod. So, and the techniques that I go through there is the same as I would do whether it's a node or a pod. So let's have a look at the diary. And the idea is, this is,
How would you know if it was a node or a pod?
I'll show you in a minute. You'll be able to see some of the kind of telltale signs that are there. So the idea of this is we've got two diary entries. It's saying the story. With a capture the flag, there's always a story that the writer has come up with, and this is the hardest part for me, is coming up with stories when I'm creating these scenarios. But it's kind of giving you a way of connecting in, and the way of connecting in that it's giving you starts to look very similar to what you've already got. There's a map that you can go to. If I go back to my desktop and look at the port 8080, which we can do. The map can be helpful in terms of we've mapped the port, we've connected in with SSH, and we've mapped the port through the SSH tunnel. It's telling us that there's a couple of different seas, the North Pacific Ocean, the South Pacific Ocean, Arctic, North Atlantic, South Atlantic. It's kind of giving us a pathway that we might follow to get to where we want to go. I've already checked kubectl is available, it's there. So I'm looking, the first thing I'll look at with kubectl is I'll give it a command and I'm looking to see if it gives me a response. Even when it doesn't give you a response or it gives you a permission failed, it's giving you information. And attackers coming in are trying to do these things. And this is why logging and monitoring is so important, is how many developers should have kubectl access to your cluster? Well, probably none. They certainly shouldn't be listing namespaces, and these are all signs of someone trying to gather information about what's going on. But we can also see that the namespaces that exist also match up with the map that we had as well. So the map kind of gives us the direction of where we might want to go. See, my brain is just going crazy at the moment, so it always goes wrong. Command here somewhere I use to see what can I do.
I've completed.
I don't think we've got tab complete set up. No. But my notes are here. So let me go back to the notes. Reset my head. Reset my brain.
Oh, yeah, have you missed a kube toggle?
Yeah, absolutely I have. That's exactly it. There we go. It's annoying because this is one of my favorite commands, and there's all sorts of things that you can start seeing about access to a Kubernetes cluster from here. Namespaces, I can get and list them, and that's probably all I can do. But there are other namespaces. Can anyone remember the namespace that we're supposed to go to next? So our map kind of starts over here, and we're probably in the Arctic Ocean because there's a skull and crossbones over there. So we can start doing this across all of the different namespaces, and I'll show you in a minute that there's different permissions that we've got in different namespaces. So North Pacific, North Atlantic is probably a good place to go next. And seeing as if we've done North Pacific, maybe we should do South Pacific as well.
Wait, not Latvia, that's the secret.
So you're right. In North Atlantic, we've got get and list on secrets. There's probably something there that we might want to investigate and have a look at. North Pacific was not very much.
Service account.
In South Atlantic, we can now see we've got service accounts. That's an extra thing. Southern, we don't have any access. Arctic, we don't have any additional access. So already I can see pathways that we can start to get through. We're going to pick the secrets because I'm conscious of time and I know secrets is a fun one. So where did we have secrets? We had secrets in North Atlantic. So we can just do get secrets. I'll spell it correctly. The secret's there. It's number 2, part number 2 of the treasure map. We can see it's buried under a data point. There's some long piece here. What we can have a look at is does anyone recognize the formatting of that?
More base 64 looks like it could be like M-shaped.
HTTP password.
So let me take it out. We pop it in a notepad. I've base 64 decoded it, so it's ready for us to go. All right, let's go back. What else did we find?
Iron code.
We had another area that we could go to where we could get service accounts. So South Atlantic, we can get service accounts. And there was something that I should have talked about that we missed, which was in here, we can see we've also got treasure map 1 and treasure map 7. So if I have a look at what's in treasure map 1, as well.
Oh,
Now you get to see what we might be picking up all the pieces of the puzzle to.
yeah.
Let's get rid of my part 2. But we know we've got part 7 as well, so let's grab part 7 while we're at it. So first thing that we saw there is secrets are not secret. We had access to get and list secrets, and we were able to use that to base 64 decode the secret. So in South Atlantic, I think we said.
Yeah, service accounts.
We can see 2 service accounts that are in there. We can see default and invader. Before I do that, does anyone know what service account we're using at the moment or how you might find that out?
In like slash run. I don't remember. I know there's a.
Can we do this? Have we got permissions to do that?
So I know we did.
We
I
don't.
know the namespaces you did.
We don't have permissions to get pods in this namespace. But what it tells us, and again, this is the learning from trying things and running the commands, is that we're currently in the Arctic namespace because it's telling us that we can't get pods in the Arctic namespace. And we are Swashbiter as the service account that we're using to do things. Even when something fails, an attacker will still get knowledge of it. Which means, as people defending systems, you have to have knowledge about someone doing something that fails as well. This should be alerting in your knock to say, oh look, someone's tried to do something that they were forbidden from doing, and then you start picking up behavioral patterns to see, is it a developer who's got access and they're trying to check some things, or is it an attacker who's come in and is starting to see these things? These are the ways the attacker kind of spreads out. All right, limited time. So we've got an invader service account. What can we get from it? Or we can run. Feeling the time pressure. I'm never going to cover all of this in the time we have available, but I want to start showing that movement, that lateral movement that putting something in. We could create pods somewhere as well, couldn't we? Is there something that we could create pods? Let me have a look at my map again. So North Atlantic, we got the secret. South Atlantic, we've got a service account. The service account's going to get us to somewhere. So it's the Southern Ocean that we're going to be going to next.
Adds equals.
I knew there was something I was doing wrong.
I lost my bash history.
Oh,
I think I'll be fundamentally unemployable.
Usually other people's bash history is better anyway.
with the equals just over there.
Stealing the bash history. Absolutely. I script every single time running to a server, just copy the bash history.
It should be available outside of the containers.
Bash history. Size.
So we were technically at time for this session. It's up to morning tea. Time zone difference. 3:45, we're over the hall for the Friday lock note, then followed by the lightning talks. Obviously, if Rob wants to soldier on and show us a bit more stuff, and is happy to.
See it through.
Let's see what I can.
Is it that the as option needs to be put earlier on in the kubectl?
It's incredibly descriptive. It's as descriptive as Python. Yeah, it's a trace name.
I'm going back. I know I've got, again, trying to rush through things. You know how your brain just disappears?
Don't panic. On the way.
But anyone who wants to go, thank you so much. There's some cards there on the side. I will carry on going through it through the tea break and demonstrate the rest of the cool scenario.
Keep the stream running.
But the pieces are there.
We'll keep the stream running.
Okay.
Yeah.
I don't know if there's anyone in the room, but they're welcome to. Yeah. I'll leave the working files now that they've all spun up in that folder. So if you want to play with it tonight, I'll probably clear it down this time tomorrow. So they'll be there for 24 hours. It might be that we've got a Reaper that is currently destroying it. So. I had to use my notes for this scenario for so long.
It's like a pack of question answer cards.
Playing card.
Sorry about the mugginess.
Thank you.
To organise a game session in it's a pack of Docker commands and concepts.
Love dice where one of them.
My gosh, it's a lot of terminology. Okay, so I mean, what is CIS?
Test my children.
It would be freaky if they could answer though. But just to have you drag them along to conferences.
I overheard my daughter pretending to be me, and she was talking all about MariaDB and pods and scaling and stuff. And I was like, yeah, that's good.
How old is
See it somewhere, but I don't know. 13.
We're just admiring it.
We're just admiring.
That's good. You're starting the
It
next.
actually is.
The examinations department bade me for using this degree exam. Apparently, I have an edge.
No. Is that a man?
Not even if I do this. But once you
What do we see? We don't see a lot. We see the UID, we can see the namespace we're in. We're not actually getting any of the actually getting anything useful from that. But we know that there's we know that it's there. And what else can we do in here? Pods. We can, that's it. We can get, delete, create, list, patch, update, and watch pods. So if we have a pod that is using that service account, then we become that service account in the pod, and that gives us more permissions to do other things with. So there we go, I'm back on track. Do we have any pods in here? There's no pods currently running, because we've also got the executability into pods as well. So we're going to need to create a pod. And I know that we probably want to do some sort of kubectl container. And the minimum that we can give it is an image. So let me try my luck and see if there's a kubectl image. Always hateful, and then we can jump into that image, that pod, and start looking at where we can get out to from there. Random person creating pod inside your cluster. Again, one of the no-nos you don't really want to see. So you should be monitoring on this, and you should have locked down permissions so that people can't create pods. You want your CD tooling, whatever your CD tool of choice is, to be creating pods and doing that and running it through deployments rather than specific pods. We've now created a pod, so we should be able to get the pods, but it didn't like my image, so let me find a better one. We have some funky control plane containers that I typically use just for these kind of things. Unfortunately, we've got one named exactly what I was looking for. All right, the first thing as well to kind of start identifying here is that we tried to create a pod, and it's doing something where we've only created one container within that pod. I've given it one -- image tag. The -- image tag should be for in this instance, kubectl, but it doesn't know where in Docker to pull kubectl from, so it's ignoring it. And this one is pulling it from the control plane offset repository in Docker. But it's still showing that there are two containers that it's trying to do something with. So it's the first sign that you've got some sort of policy agent, admission controller, that is injecting an additional container inside your pod. There's great reasons for that. And typically you inject a container, sideload a container like that for networking, policy management, like you inject Istio, or you might inject Kubernetes to add some extra bits in. So hopefully it's now finished. Crash loop backup, of course. But one is ready out of what we've got. So let's have a look. So the other thing to think about is I just created it. I didn't give it any defaults. I literally gave it the bare minimum that you can use when you kubectl run something, which is just an image name. And so it's gone and produced a whole bunch of defaults. Again, the things that it's got as default is that it's mounting in service counts tokens. but it's not using our new invader token. It's using the, I think it's using the default service account. Find it in a second. We can see Kubernetes has added a sidecar. So again, looking at what's going on in the pod, we can see all sorts of things that are happening, and we see what's failed. So blockade ship is true and ready and started. And then our kubectl is not ready because it failed. It's just telling me it's got a crash loop backup. So there's a couple of reasons that it might have a crash loop backup. But I think we can start looking at some of the other pieces that are there because that should still be running. So we should be able to start looking at this blockade ship. We know that we can exec in. Can we exec in? CTO. It should default to the blockade ship as we get there. So we're getting an error, bash is not found. I always try to go bash first, but just because it fails going bash doesn't mean that you can't get in with any of the other shells. So I'm in with SH, bash isn't available, and again we can start looking at what's available here. So we can have a look at slash, we can have a look at root, and we can have a look at home. But that's not doing it inside the container, is it? So it's able to, because I wasn't doing it, that's why. Okay, so we're using the shell now, and we can have a look at root, which we've got access to. Slash, which starts to give us some folders. That means we should probably look at them. The first thing that I saw that looked out of sorts, and it's probably difficult because it's in blue on the screen, but there's one right up here that says contraband. The scenario is all based on Pirate, so you see a folder like that, you go, ah, yeah, let's have a look. And just for completeness, the fact that we're seeing ash in both /root and in our home directory probably tells me that we are logged in as root into this container. But let's have a look at what is in contraband. Treasure map 3. So straight away, we've now seen a folder, we can access it. All we've done is we've created a pod and something has added it in. So that's how we've got that third piece of the flag, is just by doing that. Now, I'm not convinced that we're going to get anything useful there. So what we'll do is /contraband. Three.
That would be a twist.
634 is like, yeah. And
Super secure.
yeah, it doesn't like me doing all of those things all at the same time. So now that we've got it there, that looks a little bit more like it. We're up to part 3, so that's good. And then part 4 is probably somewhere else. For part 4, we really do need to get that container operating. Where are we at? 15 minutes. Let's see if I can work out why it's not. All right, I want to get there's a couple of things that we're going to want to do here, right? We know that we want to use the invader service account, so we probably need to make some changes to get that. So we'll use the other cool tool. But we're not going to run it. We're going to do a dry run. Doing a dry run, there's a couple of different options with dry run. You can dry run locally or you can dry run at the server. At the moment, I just want to do the dry run locally because I don't want to see what comes back from the server. I don't need to see what comes back from the server. But we're going to OEM that. We can have a look at it. So that's what it's trying to generate. And what we'll be able to do with that is we can output it. Probably to /temp because we won't be able to write anywhere else. We can't install Vive, but do we already have it? So instead of it defaulting to a service account, we're going to tell it what service account to use, and we wanted it to use Invader. I don't think the kubectl one is necessarily the right one. Let's get enough base, and then we can. So there's a couple of other things that we can add in here as well. In the interest of time, it's going to be blocking us on a few of them. Let me have one. So we can do that, and we can.
Bothering myself by looking at the layers in your Docker Hub repo.
Oh yeah. There's probably a better image in there that includes kubectl.
kubectl is the right image that includes kubectl.
Yeah. There's a strong likelihood that I'm going to have to create a temporary container image at some point. I think that's in this. This is normally where I have to do that. See if that does it. So we're going to apply that in what.yaml. I've got something wrong.
Need a space after the column.
Yeah. Almost like it needs to be.
Another mark.
So port and then number. I need to put it in. Or does it need number?
I don't think so, actually. That's a deploy.
I'm using the old sample that someone else created when they generated this previously. It's not the way I normally do it, but I can't find my notes, and I haven't used my notes for so long. It's like, why am I struggling so badly with it today? I don't know. It's still not unmarshalling it. I think we might call it. The idea is like these scenarios, they're supposed to be a bit of fun. Kubernetes is challenging. But the way we built them was to show common things that are broken and misconfigurations and ways that people don't think about a Kubernetes cluster being insecure. So by having a playground and having some way that you can go through and do it and try it and see the insecurities and see the things that you would have otherwise done yourself, that's the reason that we've got this platform. When we run it as a training, we use more modern scenarios. I've used the open source one so that you can go away and play with it on your own infrastructure, and I'm going to put the links up so you can go and grab some of the ones that we had there. But it's an open source project, so anything you find that's not working well, it's not quite the same as the internal one that we use, but it's worth playing with it and doing something with it and creating scenarios. And I have a challenge for myself this year to add some new scenarios to the open source library as well, because I want people to just play with it without having to pay for our services. If you want to pay for our services, I'm more than happy to come in.
I mean, I like the non-linearity of it. One of the things that I bemoan is people coming through nowadays, all the answers are out there for them. Like, you've got such a vast amount of resources, you know exactly what to do, whereas this is trying to encourage people to poke and prod and try different things rather than this is the problem, this is the solution.
Yeah. And you'll find there are write-ups of many of the ones that we run at KubeCons. So there's someone, and I think we probably did this one at KubeCon, so there will be a write-up somewhere on the internet of someone who's gone through it and solved it really quickly and written their way of approaching it. What I don't like with the write-ups, but what I like with the write-ups is my approach is always different to how I find it on someone else's write-up. So even the pod template that I was using here because someone had put it there, that's not the way that I do it. And there's things that they've done now. I'm going, why have you done that? Why haven't you done this bit? While I'm trying to talk and present it at the same time. But it is very non-linear because Kubernetes is non-linear. There's so many different ways of achieving the same objective that, yeah, you have to play with it, you have to learn it, and it's a skill.
Penetration testers have reams and reams and reams of processes and policies and procedures that they follow that rather than having to come in and type everything,
they just
it's going to curl a shell script down from an IP address that pumps text file of anomalies out that they can then look at and say, okay, that's weird, that's weird, that's weird.
And when you start bringing in AI to that picture as well, it goes through it and parses it and sees it in the same way. The reason that I talk about it as I go through is these are the things that I'm looking for when I'm looking at analyzing someone's Kubernetes cluster. Those are the things that I go, there's a red herring there, there's something going on there. Because developers will frequently leave tokens and keys dropped in a system that they were using when they needed it for development, and then they forget that it's there when it goes into production. And that happens far too frequently. So
this is one of the nice things about doing it in front of people, having an interactive audience, is someone being able to say, that's weird.
Yeah.
It brings that kind of peer-pair programming element and not being afraid to tell your colleague that they've missed something, or not being afraid to ask your colleagues to chip in if they can see something weird as well.
Which works in two ways. So you have to be able to take feedback.
Yeah.
Doing it in front of a live audience, it's a great way of getting feedback. But I really appreciate it. I love it when people say, oh yeah, you've missed that from the file, because I would have thought about it far too late for it to be of value and actually really fix something and solve something.
There's probably 4 people in the room who saw you'd missed something, but wouldn't say something for fear of offending you or for upsetting you or wondering if you were doing it on purpose. So it's good practice and it's good professional practice. I'll give you a speaker gift. Thank you so much.
Oh yeah.
Thanks.
Thank you.